Hello everyone, and welcome to the first lesson of Unit 2, Dividing Polynomials. So we will start off with some simple long division that you guys did in elementary school. So we'll start by dividing 324 by 6. Now remember the process. We take this 6 and we see if it can divide evenly into the first number, which it doesn't. So we take the 6 and we see if we can divide it into 32. So 6 goes into 32 5 times. And then we know that 5 times 6 is 30. We do the subtraction, so 32 take away 30, and we bring down the next number. Now we check how many times does 6 go into 24. Well, that's 4 times. And then we do the 4 times the 6, we do the subtraction, and we end up with 0. So this number here, because 6 cannot go into 0, we know that it is our remainder. And because it's 0, we know that 6 divides evenly into 324. Okay, let's try again. So 8 going into 6. We know 8 is too big to go into 6, so we take a look at the next number and combine. So can 8 go into 67? It can go into 67 8 times. So what we do is we take the 8 and the 8 over here and we multiply, we subtract, and we bring down the next number. Now how many times does 8 go into 35? Well, that would be 4 times. 4 times 8 gives us 32. We do the subtraction and we end up with 3. 8 is too big to go into 3, so again, that's our remainder. And because it's not 0, we know that 8 doesn't divide evenly. Into 675. So, what we did in part A is we took 324 and we rewrote it in a different way. We know that 324 can be rewritten as 6 times 54 plus no remainder. In part B, 675 can be rewritten as 8 times 84 and then add 3 more to get the 675. So when dividing polynomial expressions, these are the terms that you need to memorize. The dividend is the thing that you are dividing. The divisor is the thing that's doing the dividing, and the quotient is the answer. So taking a look at what we did in part A and part B, we can rewrite this as the dividend equals the divisor times the quotient plus the remainder. So make sure you highlight this in your notes. It does come in handy. Another way to rewrite it is in something called quotient form. So if you take a look at, again, these examples up top, 675 divided by 8 can be rewritten as 84 plus 3/8 because there was 3 left over as our remainder. So this form right here is called quotient form. A lot of the times in the examples, I will ask you to rewrite your answer in quotient form. So dividend over divisor equals your quotient plus your remainder over the divisor. So what we're going to do now is long division with polynomials. And then we'll take a look at any restrictions. So same concepts as the long division with the numbers. What we're going to do is we're going to compare first terms. So I want to know how many times does x go into x squared? Well, I know that if I took x and I multiplied it by another x, I would end up with x squared. So just like in the number example, we took this number here and we multiplied it by our divisor. So that's what we're going to do now. Take the x and multiply it by x plus 10. So x times x and x times 10. And now we subtract. X squared take away x squared is 0. 8 take away 10 gives us negative 2. And just like last time, we bring down the next number. And we repeat the process. So how many times does x go into negative 2x? So again, we're just comparing the first terms. X and negative 2x. Well, I know I'd have to multiply this x by negative 2 to get negative 2x. And again, we are going to take this number and multiply by our divisor. So negative 2 times x, negative 2 times 10, and we subtract. Negative 2x take away negative 2x, negative 20 take away 20, ends up being 0. When we end up with a remainder of 0, that tells us that the dividend was factorable. Okay, so now I would ask you to write your answer in quotient form. So remember the formula. It's dividend over divisor equals your quotient plus whatever remainder you have over the divisor. And because it's just 0, we can rewrite it as that. Okay, let's move on. Now, before we move on, we need to talk about the restrictions on the variable. Remember, you can't do any kind of division by 0. So if I am dividing by x plus 10, the restrictions tell me that my divisor cannot be 0 because I cannot do any division by 0. And that tells me that x cannot be equal to negative 10. So those are our restrictions. Okay, let's try again with another polynomial. So always comparing first terms. How many times does x go into 2x cubed? In other words, what do you need to multiply this first term by to get to 2x cubed? Well, I know I need to multiply by a 2 and by another x squared. Now I'm going to take this and I'm going to multiply my divisor. So 2x squared times x and 2x squared times negative 3. And we subtract. So 2x cubed take away 2x cubed is gone. Now watch your signs here. Negative 7x squared take away negative 6x squared. Leaves me with negative 1x squared. And then finally, we bring down the next term. Now compare first terms again. X into negative x squared. So I know I need to multiply this x by negative x to give me negative x squared. So I'm going to take this negative x and multiply my divisor. Negative x times x, negative x times negative 3. And we subtract. These terms will go away. 6 take away 3 leaves me with 3x, and bring down the last term. Again, compare first terms. X times 3 would give me 3x. So I'm going to take this positive 3 and multiply my divisor. 3 times x and 3 times negative 3. And we subtract. Negative 4 take away negative 9 leaves me with positive 5. Okay, so let's write this in quotient form. Dividend over divisor is equal to the quotient, so our answer, plus our remainder over the divisor. And if we wanted to talk about any kind of restrictions, remember we cannot divide by 0, so our divisor cannot be 0, which means x cannot be equal to 3. Here's another example where you need to make sure things are in order before you go ahead and do the division. So for example, in our dividend, we see that exponents are not in descending order. So we need to fix that. And the other thing that we notice is that while we have an x to the power of 4, we have an x to the power of 2, we have x to the power of 1, and we have a constant, we're missing the x cubed term. So to fix that, we need to put in some placeholder. Okay, so to tackle this question, we're just going to rewrite our dividend in descending order of exponents. And we're going to put in the placeholder for the x cubed term. So just 0x cubed minus 13x squared plus 5x plus 2. So that's our dividend, and we want to divide that by x plus 4. Now that everything's in order, we can start the division process. Compare first terms. So x into x4. Or what do we need to multiply x by to get to x to the power of 4? X cubed. So take your x cubed and multiply your binomial. So x cubed times x cubed times 4. Now, we do the subtraction. X to the power of 4s, they cancel out. Now, if we didn't put in this placeholder, what we would have is this negative 13x to the power of 2. Take away 4x cubed. And because the exponents aren't the same, we wouldn't be able to do the subtraction. So that's why it's really important to put in this placeholder. In any case, 0x cubed, take away 4x cubed, and then drop down the next term. And continue the process. What do we need to multiply x by to get to negative 4x cubed? Well, I need to multiply by negative 4 and then an x squared. So take this negative 4x squared and multiply. And when we subtract, negative 13 take away negative 16, so always be careful of the signs, gives us positive 3x squared. And we drop down the next one. And repeat. X to go into 3x squared, I know I need to multiply by 3x. And then we take the 3x and multiply. And subtract. 5 take away 12 gives us negative 7x. And finally bring down the very, very last term. X multiplied by negative 7 will give us negative 7x. And we multiply. Negative 7 times x and negative 7 times 4. To take away negative 28 gives us positive 30 for our remainder. So if we were to write this in quotient form, I'll just write it at the bottom. It is our dividend. We don't need to write the x cubed term in here, just as long as you use it for the division. So dividend over divisor equals our quotient. So we ended up with x cubed, take away 4x squared, plus 3x minus 7, plus our remainder over the divisor. And if we had to do any restrictions, our divisor cannot be 0, which tells us that x cannot be negative 4. Okay, so what I want you to do now is work on example D on your own. Follow along with what I'm doing if you get stuck. When the divisor is a trinomial, there is no secret tricks or anything. You're basically doing the exact same thing. You're always comparing first terms. So again, take a few minutes, work this one out, and if you have trouble, follow along with what I'm doing, and make sure you ask questions in class. Okay, now once you've gotten to this point, x squared is too big to go into 26x. So what we're left with is a binomial remainder, and that's okay. So we'll take this and write this in quotient form. Our dividend over the divisor equals our quotient plus our remainder over the divisor. Now, this one's a little bit tricky, where if we wanted to find restrictions on our divisor, we would need to find out when our divisor equals 0. And in this case, because we have a trinomial, so to find out when our divisor ends up being 0, we can either factor or use quadratic formula. So in this case, it is not factorable, so we would have to use quadratic formula. So to solve for x, or to solve for the restrictions, we would sub in to the quadratic formula negative b plus or minus the square root of b squared minus 4 times a times c, so minus negative 8 all over 2. And if we were to simplify that, becomes negative 3 plus or minus the square root of 17 over 2. And because these are restrictions, these are values that x cannot equal. And there you go. So that would be our restriction. Unfortunately, not a nice one, but still a restriction. Okay, we'll move on to example 2 now, where if we take a look at the first page, not the quotient form, but this form right here, this is when this comes in handy. So let's go over the question. Question says, when a polynomial is divided by x minus 1, the quotient is x squared plus 6, and the remainder is 4. So we want to find this polynomial f of x. So that formula, the dividend equaling the divisor times the quotient, plus the remainder, comes in very handy. So the dividend is the thing we want to find out. That is our f of x. The divisor, we know, is x minus 1. The quotient is also given to us, x squared plus 6x. And the remainder, we know, is 4. So really, all we need to do to solve this problem is expand and simplify. So x times x squared, x times 6x, negative 1 times x squared, and negative 1 times 6x, plus the remainder 4. And when we tidy this up, we end up with x cubed plus 5x squared minus 6x plus 4. So I know that when this polynomial is divided by x minus 1, we should get a quotient of x squared plus 6 and a remainder of 4. Now, the next thing I want to go over is something called synthetic division. It's an alternate way of dividing polynomials, a much simpler, more efficient way to divide polynomials. So take a look at the rules. What we're going to do is we're going to take our dividend and we're going to write each of its coefficients out. And then we're going to put our root, so that comes from our divisor, on the outside of an upside-down division box. We always drop down the first number, and then we do some multiplying. So 3 times 2 gives us 6, and then what we do is we're going to add this column up, which will give us negative 1. Then we do 3 times negative 1, gives us negative 3. We add this column up, and then we do 3 times 3, and then add this column up. It will make a little bit more sense once we go from scratch. So let's do that now. So we're going to use synthetic division to divide this polynomial by x plus 2. So the first thing we do is we write out the coefficients. We have 1x cubed plus 5x squared minus 2x minus 9. And again, the important thing you need to check for is, are your exponents in descending order, and are you missing any terms? Both of those conditions are met here, so I am okay to write 1, 5, negative 2, and negative 9. And then what we do is we are going to put the test root on the outside of the bracket. So we're not going to put the plus 2, we are going to put minus 2. Then we start our synthetic division. So we always drop down the very first number. Then we multiply. Negative 2 times 1, and the answer to that will go in the next column. And then we add these two numbers up. So 5 plus negative 2 gives us 3. Take the number you just found and multiply by the test root. So 3 times negative 2 gives us negative 6. And we're going to add the columns up. So negative 2, negative 6. Take this answer and multiply by the test root. Gives us positive 16. And again, we are adding. Now what happens here, the very last number always is the remainder. And then the following numbers are the quotient. So we have our constant, then we'd have our x term. This is our x squared term, and if we had more numbers, it would be x cubed, and so on and so forth. So to write this out, I would say, in quotient form, I would say that the dividend is x cubed plus 5x squared minus 2x minus 9 over our divisor equals the quotient, so all of that comes from right here. So I know I have 1x squared plus 3x, take away 8. Plus our remainder of 7, which is always the last number, over our divisor. So nice and simple. A quick, efficient way to do it, but there are a few conditions that need to be met. Synthetic division is really only ideal to use when your divisor is a binomial and when you have a leading coefficient of 1. So for example, 2x minus 1 would not be an ideal place to use synthetic division because of the 2 here. If our divisor was x squared plus 3, again, would not be ideal because we have the squared term there. So only when you have a binomial and when that binomial has a leading coefficient of 1. Any other time, you should probably use long division. So that's it for today's lesson. If you have any questions, please make sure you ask in class. Take care, guys.